Leave me alone. Leave me alone. Christian, leave me alone. Leave me alone.
Oh.
Yo.
You know that's a phone.
Yeah.
I see that.
Yeah.
Oh, Christian, let me see.
What?
Wait a minute.
Is it just undefined? I don't know how I got 80 and negative.
It's undefined. You don't ask what I'm doing right now.
It's undefined.
I didn't ask.
It's gotta be
Yeah.
Because 2y equals 4x plus 30 and 2y equals negative 30 plus 2.
What's that?
Undefined. 2y can't equal the same.
Go down to the clinic.
Pushed up, Summer. I'm on the I can't sleep. Glasses over your nose. Now you're trying to say.
You're not at that point.
Oh, yeah. I did that.
All right, so this one here, who thinks they got the answer? Zach, all right, so you think you got it? Preston, turn around. What did you get?
-4.7.
Okay, man, do you agree? All right, now how did you do it?
So first I subtracted 4x from the right side to the left. So I had it on the right side.
All right, so you said you subtracted 4x.
Yeah.
Okay, and then tell me what to write.
-4x plus 2y equals 30.
Okay, so you put it in that order, and then what'd you do?
And then I put underneath that I had 3x plus 2y equals 2.
Okay, so we're gonna take that equation, because you have to get them, if, it looks like you're doing elimination, so you gotta get them lined up. Okay, and so, all right, what do we do from there?
I multiplied the 3x side by -1.
So this one right here? All right, you got a positive 2y and a positive 2y. That doesn't add up to 0. You just need to make one of them negative. And so I can multiply that bottom equation by -1. That gives me -4x plus 2y equals 30. And then -1 times 3 is -3x minus 2y equals -2. Those add up to 0. -7x equals, that's positive 28. Divide by -7, and I get x equals -4. And now you got to go back and plug it in to get what y equals. What'd you say y was?
7.
7. So I'm just going to start with 3x plus 2y equals 2. Let x equal -4. And then I get -12 plus 2y equals 2. Add 12. 2y equals 14. Divide by 2, you get y equals 7. So that's how you get -4, 7. Amanda, how'd you solve it? Same way?
Yeah.
Same way? Anybody solve it a different way and get the same answer? What'd you do, Zane?
I did the. I did the what I did was I got I divided 2.
On this one?
Yeah.
Okay, you got y by itself, and then did you substitute that back up into here?
Yeah.
Okay, that's substitution, perfectly fine. It'll work. Okay, so you go through that. Jordan?
I did the
Never mind.
I never know the way to do it.
Did you get their answer right?
Yeah.
All right, so I'll take a look at it real quick here. All right, take a look at your answers here for, and we'll go over a couple. Okay, those should be your answers. I don't see, well, I have 40 and -2, but not 80.
So I did.
Yeah, I don't know how I got it.
4 times 4. So I just get rid of the X's.
Okay, yeah, no, that's fine. As long as everything lines up, usually put the X over it, you don't have to.
All right.
Okay, got that one. Where's 3 at?
You didn't have to do 3.
What was 3?
No, you didn't have to do it. It's your fault.
No, it's your fault. I got 80 -2.
Then you throw in the line.
85 -2.
Yeah.
I don't know how I
You didn't have to do 18.
Never smell the dryer.
Didn't have to do that.
How did you get -40?
For 8, what'd you get?
Yeah. 4, 6.
Well, -11.
Why do you want to break stuff?
So that's gonna be, so that's a -3 minus 8.
No.
Really?
-11. All right, listen up here. Let's take a look at 10 and 20. We set up this equation yesterday. Preston, what's the what are the 2 equations we used from yesterday?
That's 10.
H plus D equals 12 and 2H plus 4.5D.
Sounds
All right, I'm talking, stop here, pay attention. All right, we set this up. H plus D equals 12 because you're gonna have 12 packages of buns. So H is your hot dogs. All right, D is your, for H is your hamburgers, D is your hot dogs. It's yours, I'll hold on to it, because you're having issues.
All right.
On that. So you had 12 total packages. In the cost, you spent $20. So there's $2 per package of hamburger buns, $1.50 per package of hot dog buns. So this is the case here. Evan, how do you think we solved this, or how did you solve that?
Well, I did completely wrong.
You're completely wrong. All right, well, take a look at it, because you're gonna have to know how to do this. And what do you think we can do? And then we'll see where you went wrong.
Times the top by -2. That's probably where I went wrong.
No, that should work. Now, when you multiply the top by -2, because that'll give you -2H. -2 times positive D is -2D. Now, this is where usually I see a mistake. -2 times 12 is -24. Make sure you have a negative down. So now, -2H plus 2H is 0. -2D plus 1.5 is -0.5D equals -4. All right, now you know we shouldn't get any negatives because we're dealing with, the number of packages purchased. So if one of them's negative and the other's positive, that should be kind of a little bit of a red flag since they're both negative. When I divide by -0.5, a negative divided by negative would give me a positive. Well, what's 4 divided by 1/2? Okay, Colin?
8.
Should be 8. Positive 8. Well, H plus D has to equal 12. D is 8. So you should be able to just figure this out. Subtract 8, you get H equals 4. So you should get 4 packages of hamburger buns, 8 packages of hot dog buns. Okay, for that one. Now, I know we set those up, but you gotta make sure you multiply through. Now for 20. All right, here's 20 down here. All right, what did we, Christian, what was our equations that we set up yesterday?
C plus V equals 8.
Okay, and then what else?
3C plus 4.25V equals 3150.
Okay, so that's how much we spent. All right, what do we need to do to solve this one? All right, come on.
Multiply the top by -3.
Yeah, I think that is the easiest way, is you multiply the top by -3. All right, so when you do that, that gives us -3C minus 3V equals -3 times 8, which is -24. So those are all gonna be negative. And I got positive 3C plus 425V equals 3150. And then that gives us 125V equals, what is that, 750? All right, we gotta get a whole number because you can't have a fractional number of candles or a fractional number of vases. Colin, what's that equal?
V equals 5.
Okay, good. V equals 5. So C plus V has to equal 8. Is it 6 or 5?
It's 6.
Yeah.
Use a calculator.
It's 6.
I think it's
What's it on the board?
Well, 5 times $1.20. I don't think it's 5.
I got
It's 6.
We'll try it again, Colin, to make sure.
I literally can't get an calculator. I don't know how I got it wrong.
So C plus 6 equals 8. Subtract 6. C equals 2. All right, so that's what we're gonna get there.
Did you divide it by 1.5? That's how you get the 5. You might have forgotten to put the 2 in.
Also, sometimes I click it and it doesn't work.
Exactly.
I know.
You
2 candles, 6 vases.
So like,
All right, for that one. Now, we need to cover one more section, and it's gonna be, special systems. So we're gonna go through those in class items. So, let me give you the notes here for today. The next slide is not on your notes.
How much time do we have to do that tonight?
What's that?
How much time do we have to do that?
Probably about the same amount as last night. How much long did that take you?
Like 10 minutes?
All right there.
Come on, then you do it.
Evan has his nose covered. I think he's okay, so. You landed in car. Oh my God. Look at it, you have. Why? Trust me, my desk must be strong, because I hit it so hard with the controller. I was talking to Evan, I literally have to stand at my desk because of the controller.
Controllers are.
Yeah, they're actually pretty.
Uh-oh.
Probably for a reason.
Someone breaks it, I just have to throw my controller out.
I heard one time someone,
Better way, Rachel.
Oh, yeah, sure.
like, if you throw it at the wall, it'll probably make your desk.
If you go through and not hit studs.
All right, we're not gonna do anything like new. It's just kind of how the answer appears. So for this first one, now this one's not on your sheet, so just pay attention to this one. It says solve it by graphing. So you got to graph y equals x minus 4. What is the slope of that line? Because you're still going to need to know how to graph on the test. Okay, when we take that. George, what's the slope? Do you know?
1.
It's the number in front of the x. If there's no number written, it's 1, or you can think of it as 1 over 1. Y-intercept, London. Do you know any idea what the y-intercept is?
4 or -4?
-4. So it's 0, -4. So that goes right here. Slope is 1, up 1 over 1, and it's a positive. So this line, okay, looks like that. Now the other line, which is y equals x plus 3, it also has a slope of what? 1. Slope's the number in front of the x. Its y-intercept is 0, 3. And so I'm going to go up 1 over 1. And now I'm going to connect.
Doesn't even make sense.
What do you notice about those two lines?
They will never intersect.
It will never intersect. Now, if you are, listen up, please. If you are asked to solve the system, you're trying to find where they do intersect, and you just said they don't. So that means this system does not have a solution. No ordered pair will work for both of them. Okay, so this is kind of where we come up with these special cases, is sometimes we're used to coming up with a point. Well, here's what happens. We get 3 things. Now, this is on your guided notes here. This is at the top there. 3 things can happen when you're solving a 2x2 system. Now, the first one says, with that blank, you're going to get one solution. Put that. Okay, that goes where that underline is. That means you get intersecting lines. Okay, so if you would graph them, at some point, the lines would cross. Okay, at some point, the lines would cross. So you would get one intersecting lines. If I just give you 2 equations, how do you know those are intersecting lines without doing any work? Colin?
The slopes are different.
Yeah, as long as they have different slopes, the number in front of the x is different. That means at some point they're not going to be parallel. So at some point they got to cross. Okay, so that's going to be the case there. So you can get one solution. Now this next one can be a little bit hard to understand the first time. You can get infinite solutions. Well, what does coinciding mean? Okay, coinciding. Basically, it means it's the exact same thing. They are both the same. Okay, so coinciding lines means they're exactly the same. Now, it could say y equals 2x plus 4 and y equals 2x plus 4, but it's not usually going to be that obvious. So a lot of times it's going to look like this. You're going to look at those initially, you're going to say, well, those don't appear the same yet, but if I would take this top one and I would solve that for y, I would subtract 3x and I would get 2y equals negative 3x plus 8. Then I would divide everything by 2. And so I get y equals negative 3 halves x plus 4. So they're exactly the same in the end. And if you would graph them, you draw one and the other would be right on top of it. So they would hit at every point. So that's infinite solutions. And the third one is what we just looked at, is no solution. You're going to have parallel lines. So when we talk about a line, it is always a straight line. Can 2 lines cross 2 times, like just twice? No. If you got a line here, and any other line that I draw, it can only hit it at one point. And these are the other 2 cases are it can both be the same line, which would be infinite solutions, and the third one would be no solution, which is parallel lines. Well, if I just give you the case, you should be able to look at them and tell me whether they're infinite or no solution. Okay. All right, now that's this little chart to your right. If they have one solution, you will have different slopes. if you got infinite solutions, which means they're the same line, you have to have the same slope and the same y-intercept, because everything has to be the same. But if you have no solutions, you have to have the same slope, but you gotta have different y-intercepts, okay? So these are the only three things that can happen. You can get one solution, infinite, or no solutions. All right, let's solve this by substitution. Let's kind of review, go kind of back through that. Is that that's the same one you got, right? Okay, so do I have one of the letters by itself? Yeah. So for the first one, now for substitution, I like to write them beside each other. And that means I'm gonna take this, I'm gonna plug it in for y. If there's no number in front of the y, I can just write the new expression in there. So it's gonna be negative x, take out the y, and put in positive x minus 4 equals 3. Okay, what happens when you simplify that?
X is 0.
X is a 0. But what am I left with? Okay, short.
Negative 4 equals 3.
But you gotta put down negative 4 equals 3. But there are no x's. Well, what does this mean, negative 4 equals 3? We've kind of come across this before.
No solution.
It means no solution. I mean, that's never true. So that means these two lines, what can you tell me without even graphing them? What should you be able to tell me about these two lines? They are going to be parallel. So that would be the case here. This is no solution. Now, since it said solve it, I mean, that would be your answer, but you also need to understand that means these are parallel lines. You would graph it. So if your x's cancel out or your y's cancel out, you get something that's not true. It's no solution. All right, we gotta look at this second one. Y equals 3x plus 2. All right, 3x minus y equals negative 2. All right, I do have y by itself. Okay, I do have y by itself, so I can substitute it. Now, if there's a minus sign there, you've got to be extra careful. Because when you write this down, it's going to be 3x minus the quantity 3x plus 2. Now, what do we need to do with that minus sign that's in front of that? You got to distribute it. Treat it like a negative 1. And so now this becomes 3x minus 3x. Negative 1 times positive 2 is going to give me minus 2 equals negative 2. All right, what does that simplify to?
Negative 2 equals negative 2.
All right, negative 2 equals negative 2. So this is slightly different than the last one. All right, negative 2 equals negative 2. What's that going to lead us to? Okay, Jordan?
Infinite solution.
This is infinite solutions. They're going to be the same line. If you get a false statement like we had earlier, like negative 3 equals 4, that's no solution. If we get a true statement, that's infinite solutions. So this is what it looks like for substitution. This is what it looks like for substitution. When you substitute in, your x's cancel out or your y's cancel out. You end up with either a true or a false statement. All right, what's it look like for elimination? So you get 2. Now for elimination, I'm going to keep them in this order. 2x minus 6y equals 8. X minus 3y equals 2. What can I multiply by in which equation? Christian?
The bottom one, you can multiply it by 2.
All right, if you
All
multiply.
right, negative 2.
Yep, got to make it negative 2. All right, go ahead and do that. And the top one I'm going to keep the same. When I multiply by negative 2, I get negative 2x. And then I get negative 2 times negative 3, which is positive 6y. And then I get negative 2 times 2, which is negative 4. All right, what happens when I add? Jordan?
You get 0 is equal to like negative, or get 0 is equal to 4.
Yeah, you get 2x minus 2x is 0, negative 6y plus 6y is 0. And I get 8 minus 4, so I get 0 equals 4. I cannot just stop there, because it asks you to find a solution or solve it. So this is going to be a what case? It's either going to be no solution or infinite. So in this case, it's going to be no solution. Okay, so this is no solution. Okay, no solution. Now, when would it be the same? If you ended up with 0 equals 0, or like, that's typically what happens with this case. That would be infinite solutions. Now, this is where some people try to do too much. The directions just say what? Give the number of solutions. What do you think my options are for the number of solutions?
Wait, for all like.
Yeah, like what would the answers possibly look like? Alex?
One solution, one solution.
Yeah, you would just say, all right, it has one solution. You would say it has no solutions. Or we would say it has infinite solutions. Do not try to tell me what the solution or solutions are. Don't say like 2, 4. I don't want that. You got to read the directions, give the number of solutions. What's the easiest way to do that? There's just one main thing we need to look at. You got to look at the slope. Now for the first one, let me look at the second one. Y equals negative x plus 3. What's the slope of that line? Negative 1. Slope is negative 1. Now for this one, y equals negative 2 times x minus 1. Distribute that negative 2. And now we got it in slope-intercept form. What's the slope of that line? Negative 2. So from this information right here, you got enough to tell me, is it one solution? Is it no solution? Or is it infinite? Joe? 3? What do you mean 3? These are your only options. One solution, no solutions, or infinite. Okay. No solution, Sam.
One solution.
All right, it's one solution. It goes back to if they have different slopes. Okay, if these are different. And it goes back to that chart on the front. Oh, where'd it go? Okay, different slopes, one solution. Same slope, same y-intercept, infinite. And if they're parallel, same slope, different y-intercepts, then they are no solutions. All right, so for this one here, before you say yes or no, get it in slope-intercept form. Get them both in slope-intercept form. Before you say 0, 1, or no solution. So for the first one, x plus y equals 5. And 4 plus y equals negative x. So just get y by itself for both of them. And for the first one, I want to subtract x. And I get y equals negative x plus 5. And for this one, I want to subtract 4. And I get negative x minus 4. All right, from that information, Brett, what do you think? One solution, no solutions, or infinite?
No solution.
No solutions. You have the same slope, but different y-intercepts. If they're exact same line, it'd be infinite solutions. So that's going to be no solutions. Okay, no solutions. All right, now go ahead and get started on this. Like I said, we're going to start reviewing for the test tomorrow.
How come we haven't talked about exams yet?
Because we'll start reviewing on exams on Friday. Your exam will be Thursday and Friday next week. It'll be a 2-day.
Why are we like going over everything?
Because we haven't needed to yet. We got plenty of time. We'll do it next week. Monday, Tuesday, and Wednesday. What happened here?
Be that way, all right.
No. Did you?
Regular integrated touch, we're not smart like you.
It's the same class, just give you a fast.